My name's Tripp Shenton. I'm from the University of Delaware, and I'm also the academic director for the Northeast Partnership. Glad to be here this morning to moderate this session on maintenance and repair of corrugated metal culverts. I think in the years that I've been coming to meetings and associated with the partnership, I don't believe we've talked about corrugated metal culverts before, so I know there's certainly a lot of them out there, and states have had issues with them, so we thought this might be an interesting topic for the meeting. We've got, we're going to have a panel session. I have 4 states represented, then we're going to have a Q&A, open discussion. So just to start, on our panel this morning are Jennifer Hawkins. She's from New York State Department of Transportation, Office of Transportation Maintenance. Jason Arndt from Delaware Department of Transportation, Bridge Management Engineer. Rod Thornton from Maryland Department, State Highway Administration, Office of Structures, and Jeremy Salvatori from our host state, Vermont, Bridge Maintenance Project Manager. So you'll be hearing plenty from them. Just to, in preparation for this, did a little bit of research to kind of see what's available out there. Pretty easy to get to in terms of resources in how to deal with corrugated metal pipe culverts. There is an older 1995 Federal Highway document, the one shown in the upper left there on culvert repair practices. That one covers all types of culverts. It's a pretty extensive 2-volume set. I know in the second volume, which has a lot of the details, it has about 42 items with detailed procedures and processes for repairing different issues with all different types of culverts, and so there's a number of sections in there on corrugated metal pipes. Some of the states have some manuals already out there that you can find online, and so you see Connecticut does, and Minnesota. A couple foreign documents there just pop up when you do the dive down into the literature out there, and then there's also a USDA document. Not saying this is covering everything out there, but just some of the things that you would see pop up if you did a search online, and they're relatively easy to get a hold of. I was asking the question for myself is, well, is there any research going on today out there in repair of corrugated metal pipe culverts? And there hasn't over the years been a lot, not that I could find. It turns out that there is one pooled fund study going on right now. That's in that first box at the top there. You can see structural design methodology for spray applied pipe liners, and that's led by Ohio DOT. I think it might be, I don't know, 5 or 6 states that are participating. Any states here aware of this project and participating? Yes? Not 100% sure? I'm not. This is being led by, the lead DOT is Ohio. The lead DOT is Ohio, and I think the work is primarily being done at University of Texas at Arlington. So, and I think it's probably got about another year or so to go before it's done. But also that middle one, that's just something pops up about the conference, the concrete conference in Virginia a year or so ago, and then a paper down there from about 4 or 5 years ago. So not a tremendous amount seems to be going on in terms of on the research side for metal pipe culverts, but is a little bit. With that, we're going to go ahead and get into the panel. The way we're going to do this is each panel member, it's going to take about 5 minutes just to kind of talk about their experiences and in their state with their metal pipe culverts. They each have given me some slides, and so we're going to start with Jennifer from New York.
Jennifer Hawkins, New York State DOT. I'm currently the Bridge Maintenance Program Manager, and also I recently took over drainage, which I haven't had a lot of time to spend on, but I did manage to gather some pictures. Fortunately, I did where and when emergency designs for the department probably about 10, 15 years ago, so I've seen a lot of culvert rehabs. This one here is one of our favorites that the crews can do. You know, rusted out culvert, and they can go in and shove a HDP pipe in. Lots of times if they can't get grout in, they don't worry about it. They'll then just form up the head wall, put in, stone for erosion control, and call it a day. We've also tried a lot of these. As you all know, they're kind of environmentally sensitive, so it has to be in the right location. Obviously, this one is kind of just running into a ditch. It's a smaller one, obviously, but we have tried larger ones. Again, with the stream temperatures and all of the chemicals, we've kind of shied away from this unless it is a location where it's not stream. Some of the bigger ones that we've done, usually we don't do these by state forces. Our state forces are there to help. Actually, this one, it does look like it was state forces. I see our big yellow truck up there. So we are capable of doing stuff like this. We work with our structures design folks to, help us with access and what we have to do on the inside, and then, filling it in with grout and getting the grout pumps in there. And dewatering is sometimes an issue, but usually we try and do them in the dry. We've also done some of these steel culverts. They're pre-designed. This one's actually a pedestrian bridge, but we have done culverts with these as well. Very, very successful. We like them, but again, it's very difficult for our crews to do them. I think we did a 6-foot round one, and it went really, really well. So this is another option that we have that we're trying. This is one of our favorites, the big, huge, almost bridge-sized culverts under the interstates. We'll go in and we'll, throw rebar in, have our structural engineers determine if it's, rotted up to the structural line. If it is, we will then put in, rebar and plan to fill in on the sides to make it more structural. Lots of times, if it's okay structurally, we'll just go in and pave the invert just to kind of seal everything up. This one, we found it was the becoming structurally compromised. So again, went in, poured the floor, and then put the rebar in and poured up the walls. This was done by state forces too. Across the state, it's varied in our crews' specialties and skills. So downstate, we don't have a lot of time and resources, money, labor to do it, but upstate in our North Country, right across the lake, they're able to do this kind of work. And it's actually the highway side of the house that owns the large culverts, but lots of times we'll have the bridge folks come in and do these repairs for us because they're skilled in, rebar, forming, pouring, and so bridge helps them out. And obviously this one, there wasn't any issues with fish passage or anything like that, so it was just a smooth bottom. We do have our hydraulics engineers come in, probably with this one. We would have the hydraulic engineer do a study to make sure, that we could do this. And environmental folks obviously are involved. We've also tried to do some shotcreting. So our North Country folks, they love this shotcreting. So they've gotten really, really good at it. And again, they're finding that it's a lot easier than that whole labor intensive of the forming and pouring, especially if it's still structurally intact. And of course, getting the environmental folks involved. This one, we have the little low flow channel and the little fish passage. And this one was, I think they said it was probably 50 to 100 feet buried. So they had to build stairs down through and to get all the equipment and the crews down there and stuff. But the crews really enjoyed doing this one, something different for them.
Next is Jason from Delaware.
Jason Hart from Delaware, the bridge management engineer. So probably starting back in 2005, 2006, our inspectors started finding a lot of corrugated metal pipes that were really bad conditions. Around that time, we were starting to close a lot of roads because of them. They were that bad. Did a quick investigation, realized that a lot of these used to be timber culverts or little small timber bridges back into as early as the early 70s that were starting to fail. So at that time, the districts they must have had a good corrugated metal pipe salesman come through, and that's what they would replace these things with. At that time, it was probably the right way to go. Did a query on our database, and the ones that we were having to close, they were right around 30 years old. And as I said earlier, that most of these structures, as they probably started in the mid 70s to late 70s is when they started replacing these on up through the 90s. So we realized that we have a lot of these structures that are 20 to 30 years old. So we saw the storm coming essentially. In 2010, we had 2 actual failures. Unfortunately, no one got hurt. Over the years, as of, I guess, late last year, we had replaced 200 of these. We still have about 200 left. This year already, I think we've replaced about 10 or 12. So in Delaware, I guess we're pretty fortunate. Most of our state's flat, so you guys are probably maybe a little envious. Doing open cut excavation and replacement's pretty easy because, I mean, most of these are a couple feet of fill, so it's pretty easy. Fortunately for us, our two southern maintenance districts are really good at replacing pipe, which is where most of these corrugated metal pipes reside or did reside. So if we can, we would, through our district, we'd have them replace it, and they usually use HDPE. If it's too big of a structure or if there's utility constraints or something that they just can't work around, I would get kicked to our bridge design section. And they would, do the hydraulic analysis. If it's, first of all, confirm that, we can replace it with pipe, go back with pipe. And if we can, our preferred is reinforced concrete pipe. Sometimes for the larger corrugated metal pipe structures, do the hydraulics, and you either have to go back with a larger reinforced concrete frame, maybe 18 to 25 feet, or even some of these, you have to go back with a pre-stressed box beam bridge. So the ones that, we could replace with pipe, bridge design would put out a contract and get the pipe replaced with RCP. Our bridge design section about 2 years ago, they kind of did a bundling project where they took, I think there's 40 of these structures that they were in fair condition, they weren't poured just yet, but basically trying to bundle them in one contract to get them replaced quicker. It didn't move as fast as we would have liked it to, but it's moving. So I would say probably 98% of our pipes, bad CMPs, we were just able to replace in kind. We haven't messed around with pipelining a whole lot. We have done about 2 or 3 in the past year and a half. Not the greatest success so far, so it's not looking good for us. We have poured some inverts on a handful. Mostly those are ones that are in a subdivision or something. It might be a dead-end road, so we didn't really want to replace it back then and cut it off, so the easy thing was to do is just pour a concrete floor. In fact, there's one right there. That was probably about 10 years ago, and just recently that one of those culverts that we poured the concrete invert, now the corrosion line just basically moved up, so now we have to go in there and replace it. That's pretty much it. We do not use corrugated metal pipe anymore in the state of Delaware, so hopefully there's no corrugated metal pipe manufacturers here, but that's basically it.
Rod?
Our experience with paved inverts has become quite a history. Back in the 90s, we started finding these issues. As it's been said before, no longer are we using corrugated metal pipes in the state of Maryland. What we've developed is a whole bunch of standards that we now use that are actually structural repairs. Back in the 90s, we actually had a hoop design developed, and a program that we have a Excel spreadsheet that we use to calculate how many rebars we actually need to do a double weld on the sides that are good. We identify the corrugated bad areas as we call them B bars, where basically it's one tack weld every 3 feet. And then on the sides that we're actually making the structural attachment has to be good pipe, which requires then in cases where there's a protective coating that still exists, in a case like this where they would chip off that protective coating, expose the space steel, and then attach rebar to it, and then come back, and we use a 9-ground bag mix, and essentially that gives us, as you can see here, a new concrete line pipe that, from the stresses that through this calculation, transfers whatever that arch in this corrugated metal that's still intact, that doesn't have any corrosion, to this new rebar pattern that goes back into the concrete new section, and then transfers it to the other side to complete the circle. Environmental issues, we've gone through several situations. Essentially, the motivator of us paving a lot of these is the fact that some of these are under our beltways or under major highways under 30, 40, 50 feet of fill. So therefore, the option of actually replacing it is not there. Then on the hydraulic end of it, there's the pressure of not being a reduction of the hydraulic opening of the pipe. So therefore, we hit this 10% limit is what we've established as being our hydraulics and MDE, that we can actually pave as much as 10% of the hydraulic opening reduction. And with that, we have a spreadsheet that calculates for any type shape. So all you got to do is put in the dimensions, and we get the hydraulic reduction, and we try to pave down to that. But what we found is we should always try to achieve a 3 to 9 because you never know what the flows are going to be, and actually the rise in the water above these edges, that when we do pave, we typically try to slope that edge, but if it's down close enough to the water level, that's where you get a continuation of the corrosion. So to combat that, if we put a tar coating, if you notice some of these photos, we actually put a coal tar epoxy and paint the rest of the arch of the pipe that actually still had exposed steel, and we cover the tops of the concrete so that prevents moisture and actually air from getting to those two intermediary surfaces and starting or initiating corrosion, which is something that we found also. But in the general sense of our operation, we consider pipes that have like on the Eastern Shore, it's relatively flat, like Delaware has, where you have little cover, so we'll go and look at the option of actually replacing the pipe as opposed to doing the paved invert. The costs that we're getting for paving is about $25 to $35 a square foot. So it's sometimes on the Eastern Shore, if we can do a job in a replacement a weekend, it actually benefits us to do it where we replace it as opposed to paving it. But of course, on these larger pipes, we've done 12, 15-foot diameter pipes, and they're under a lot of fill. It's actually advantageous economically. It's advantageous economically to go ahead and just pave the pipe. So we've had some in the ground with the new paving for many years, and they showed great signs of functioning just like the pipe would if it were a concrete pipe in the area that we paved. We do have the options where we've also done liners. Again, the hydraulic reduction is a key component. The issues that we've faced environmentally, and everybody must face these, is the fact that you have fish passage issues now that they're pushing. The hydraulic, a recent one is the pH issue, but also the conversion of pH due to the putting a grout into the stream, but also the issue of the hydraulic acceleration of the queue. Because of the smooth surface, you actually get more volume of water through. So then there's the degradation of the channel on the outlet end, and that's something that the environmental people are kind of fighting us on, and we're trying to actually develop means of remediating that at the outlet end so that we don't destroy the stream channel by doing this operation. We've done so far, 500 pipes so far we paved. We did it sometimes with our open-end contracts and sometimes doing advertised jobs. But as a whole, we have 1,383, so we still got a little ways to go.
Jeremy?
The condition of the existing pipe and hydraulics often determines what we do for a repair. Primarily, we'll do concrete inverts or slip liners. I don't have any pictures of it, but new this summer, we I believe did 2 projects that were the spin cast. Our ANR, Agency of Natural Resources, the stream alteration, they have given us some good guidance on rehabbing culverts. We work with them early in the process. They in turn work with the fisheries to determine if we need to do anything with AOP. So that can be as simple as just a baffle, and then it can be as extravagant as doing backwatering weirs, which there's a few pictures, slides. But so this guidance dictates what what kind of baffle for what shape culvert we have, and also gives guidance on the spacing for the backwatering weirs if they're reinforced or unreinforced. All these repairs are done by contractors. Right now, our state forces aren't doing any of them. A lot of our liners, well, that's a bad picture, but a lot of them have a lot of cover, so it's advantageous not to have to dig the road up to replace them. One thing we're trying to do is with new pipes, we're trying to oversize them so we can easily line them in the future and have the hydraulic capacity to do so.
We'd like to open it up now for just questions and discussion. We have some questions for the panel in hand, but we'd rather take them from the audience to start and see what discussion there is.
How do your agencies handle 1.2 bankful and natural stream bottom? I know in Maine, A lot of these 6-foot culverts that we're doing here, we're not allowed to do that. They're now becoming 22-foot bridges. We've gotten away from the metal culverts, like some up here, and these are for the over 10s. We've gotten away from the metal culverts. We're having to put in oversized concrete boxes, bury them a couple feet, and then go in with a bobcat and push some streams in, push some nice rocks in, so our aquatic organism friends can live happy. I was just wondering how your states were handling those situations.
When we first started replacing these, we had quite a few different environmental concerns, questions. If we're replacing with pipe, we eventually convinced them that we're not going to push, especially for the smaller ones. We can't put sediment in these things. Even if we did, it would just wash out. But when we go to replace like some of our larger reinforced concrete culvert bridges, typically we shy away from box culverts just for that fact, and we'll actually go with more of a frame culvert. That way we have sediment. But we have for the larger ones that we did some box culverts, and we put fill back. I mean, the fill just washes out. I think it does it everywhere.
It does in New York as well. Yeah, usually we send anything that needs to be replaced, we will send it to our design side of the house so that they can work with the environmental folks, and then it goes to contractor.
I feel for you, Ben. We're the same boat. The stupidity here is that it's just like when I was talking about the degradation of the channel just by increasing the flow, is they all want to achieve this fish passage, the hydraulic opening. You can't flood people upstream, you can't flood people downstream. And just like you said, burying the box, 2 feet or a foot to get that natural stream bottom, and then it blows out. It's like, it doesn't make a lot of sense to them. Someone does, whoever made the laws, but we're in the same boat.
Here in Vermont, yeah, it's the same thing. When we replace them, we often have to bury them a foot or two and also put baffles in. So it can be a challenge for the contractor, depending on the size of the culvert, of how to put that stream bed material in there.
What type of, in Pennsylvania, we do concrete lining of the inverts. We do liners for culverts similar to the panel up there. We also, recently, our northern engineering districts in the northern estate come up with a structural shotcreting repair for arches. What general issues have you found with your DOT department crews with shotcreting metal culverts? Because the reason I ask that is a lot of our engineering districts aren't doing it yet, but some of them are, and I think it's a workman issue.
Yeah, we've only done 2 of the spin casters, and that was a contractor. Doing the shotcreting, wouldn't be something we would do with state forces.
I was going to say that because of the success that we've had with the paving, with the 9-bag grout mix, we haven't used any of the shotcrete just for the purpose of when we were using it on substructure units, and I guess the gunman had to be an artisan to actually have it work properly. So you had to have the right moisture on the existing concrete, so when you shot it on there, it actually stuck. It didn't suck all the water out of it and cause it to not kick off. And all the issues that you have outside, shooting an area, I can't imagine shooting it inside with somebody unless it's, we know there's a product out there that someone has. We haven't used that yet, again, because of the fact that we're trying to achieve a structural connection between the existing pipe and our paved invert, and with the success that we've had and the price that we're getting, actually, in all honesty, I mean, it supersedes, especially when you're talking about, we have a lot of pipes, older pipes that are under our beltways that are big, and there's just no, you can't spray all the way around. Hydraulically, you're going to be having to jack another pipe next to it, or 2 pipes next to it, to get it to work out. We're just not in the interest because we see no benefit of going to something that potentially could or could not fail. And hydraulically, we don't see it operating unless it's so thin, but then you lose that factor of actually, is it going to be a structural repair?
Right. In New York, we have 10 regions, and only one of our regions, the North Country, is doing shotcrete. The regional bridge maintenance engineer has been regional bridge maintenance engineer for about 14 years. He's very progressive and likes to challenge his crews. So he's the one that started shotcreting probably around 6 years ago. And it's been a huge learning curve for them. And, working with the, manufacturers and the vendors to get everything just right. And he is very, very good at selecting the right culverts to use the shotcrete. And like you saw in that one, the last picture, you know, they can get pretty creative and they have fun with it. Our Long Island region recently came up to the North Country to learn how to shotcrete. So they bought the machine, but then we had a little bit of turnover, change of personnel, and they haven't really gotten into it yet. But I'm hoping that they do, because they felt that they had some locations that they could do it as well.
Are you using wet or dry shotcreting?
I believe it's wet. I'm not quite sure. I haven't seen it. Well, I did see it in action. They're actually shotcreting a lot. They're shotcreting abutments, doing, you know, those kind of repairs as well. I believe it's wet.
What are you getting for expected service life out of these? Some of them in our bridge design group feel it's a 15-year repair, although our oldest one is 26 years old and it's still rated a 7. So I wasn't sure what you think you're getting out of it.
That I do not know. I'm not quite sure.
Yeah, we're 29 years or 28 years or whatever it is, and we're the only issue that we have, the ones that we've advertised through our advertised contract process, is that the inspection sometimes falters, and there's been pre-releases of water into the pipe, and it's caused like grooves cut into it. But even those, if it was cured finally, you know, it didn't retard the curing process by having so much water in it. We've had no issues other than just the quality of the workmanship, by the fact that, like, we like to have the edges sloped off. We like a nice uniform edge all the way across. We, you know, there shouldn't be grooves. It should be very smooth. I'm sure you saw some of the photos. It looks like almost like a concrete surface. I mean, you can see where they trowel, but it's beautiful where they typically, our contractors will go a little bit extra. I mean, ours, we put 4 inches of concrete, put number 4 bars in a longitudinal direction and a transverse direction. It's like a solid pipe. I mean, it's our concrete pipe, so we're completely satisfied.
In Delaware, we haven't used shotcrete for that type of application. We have used it for some other areas on other bridges for like abutments, beams, and stuff. It's been a bag of mixed results. Like Rod had said, it really depends on the person doing it. It is a little bit of an art.
Yeah, Rod, or the other panel members, Rod said that they do have standards that they've developed to be used. Have the other states done that?
Standards for, no. Other than, say, like the guidance that the stream alteration engineers have created, yeah, we don't really have any other guidance.
As I mentioned, we do a lot of open cut and just replacements, but we do have, you know, standards and specifications for that. Our bridge design section, more recently, they do have a spray liner spec standard.
Actually, the detail that I came up with our construction folks back 2006, 2007, welding in shear studs, it was a huge culvert under I-84, 2 huge ones. So they wanted welded shear studs put in along with the rebar, pouring up. So that sketch has actually become our standard detail.
Having that we've done 500, you know, it's just we want consistency so that we have actually advertisable details that the contractors are used to seeing. So we've done it for so long and we have so many out there that hopefully inspection does a better job of always making sure they follow it. But that's, you know, the notes have been modified. I mean, we have 2 sheets or 3 sheets of notes that we've modified because of environmental issues now have changed. When we talked about the pH, that's an issue where now when we dewater, if we have like a series of pipes, we may be able to do like 2 at a time on one side paving and then the other 3 carry the channel. But if there's any seepage or any water that gets from our construction area into the stream, and they do monitoring, I had a whole bunch of things that I gave Tripp saying that the environmental, if you get over one hurdle, they figure out another one. And so basically now they're talking about tier 1, tier 2 streams. Certain requirements are required, and there's actually a tier 3 now. I think they invented it after we started meeting tier 2s. So we have to put dry ice in the stream when the pH starts spiking to bring it back to a neutral. But the ironic thing is, again, they'll tell you they want neutral, but then you look at the stream channel farther up from the structure, and it's whatever it was, but they want it neutral at the site. So it's like, where's the logic here? Why wouldn't we try to achieve or make it the same as the rest of the stream? But it's, you know. But going back to when we do a project where we do it multiple times, again, like 500 times, We definitely create standards. So we have liner standards. We have the different shapes of pipe standards just because of the nuances of an elliptical pipe versus a circular pipe. We have even lined concrete pipes, and in my slide you saw that we actually lined concrete boxes to reestablish the invert. The environmentalists that allowed, the agency that allowed us to do that, they may have had a wild hair and just said, hey, give it to them anyways, it's already concrete, but sometimes it works out in our favor.
This doesn't go necessarily pertain to what you had asked, but Rob mentioned inspection. So when we first started finding these bad culverts, one thing we realized on the inspection side is that there was a lack of consistency as how they were being inspected and rated, and the correlation between, we're an element state, or we were back then, we still are, the correlation between the element condition states and the MBI ratings. So what we did at that time is revamped and provide specific guidance for corrugated metal pipes. That way everything's consistent. And more importantly, we wanted to find these things before we have to close them. We geared everything and correlated the element condition ratings to our MBI condition ratings such that it comes on SD4, but we have a good 4 years left in that culvert before it, we'll have to close the road or really have an issue. That way we can get a project out and have it replaced in time. And that's helped out a lot.
I heard the mention of coal tar epoxies, and I'm curious if you were using any other techniques to increase service life. One of the reasons I mentioned this, I know that Indiana is now doing, this is for the concrete repairs, such as shotcrete and such. Indiana is now going to shotcrete repairs and starting to use galvanic anodes to increase service life in some of the steel culverts.
I'll say this has been like an evolution process, just like I was saying about how the environmental changed the target or the goals. As we've seen these installed, our first one does not look like our standard. It didn't have the same general notes in the specifications like the coal tar epoxy, and may not have had the slope at the top so that water drains off the top. We didn't do the 3 to 9 space. As we progress, and if there's something else out there that someone says, hey, putting in a zinc anode and these things would help. But I'll go back to the idea, can give you an example here. The rebar that we weld, and like I said, there's a pattern of bars that we put on the sidewall on the good 100% section of pipe. Those are tack welded on both sides for every foot, and there's a number 4 bars. Then when you get to that B bar that's in the middle where it's very deteriorated, that's just every 3 feet, and that's just if you can. I mean, it doesn't. But the idea, though, is that we're getting that structural connection between the two, and therefore, we're seeing a performance that everything's working out well, so we don't see that disconnect. And actually, as long as those A bars are in connection, the pipe itself, we're happy with the performance. Now, I will say we did, and of course, you do something new, you're going to find out you make errors. We did have one pipe that actually the whole mat did separate from the pipe. But when we went to find out what happened, we actually found out that the contractor, going back to our inspection, never welded any of the bars to the pipe. And it's 1 out of 500 that we found out. I mean, I was amazed when I saw it. It was, a couple, 2 years ago or whatever, but it was not welded. And just to explain how sometimes we have bad inspection, for the first, it was maybe a 200-foot long pipe. For the first 50 to 75 feet, they had paved, and we snap a lines where they're supposed to, chalk line where they're supposed to pave up to. Well, as you got farther into the pipe, it started dipping down to where they were basically a foot below where they were actually supposed to pave, maybe even 1.5 feet. The inspector never went in. It was accepted, went out, maintenance, our inspection went out, found out that they only paid 50 feet, and then they just dropped what they were doing and stopped doing that high up on the side, because it requires, and we've actually done this on a main I-595, which is between Annapolis and Baltimore. It's, I think 8 lanes in this area. We actually have a large pipe, 25 foot of fill. I can't remember the diameter. It might have been a 10 or 12 foot diameter pipe. We actually, because hydraulically we could do it without reducing 10%, paved up to a good part that was more like at the 10 o'clock level. So we actually put forms and actually cast it and did it in sections. And that one's been fine.
Speaking to the extra coatings, I don't think I know bridge maintenance has not done any of those. As far as the galvanic anodes, maintenance side of the house are not using them. Unfortunately, we've tried them on bridges, bridge decks, but we're just finding that we don't have enough time to tie those in along with everything else that we're doing with our time and lane restrictions on a lot of our roads nowadays. We just don't have the time to do it. I know that they are trying them on the design side of the house where the contractor, the road's closed, they got the time, they can put them in. So we are trying them.
We haven't used any coatings as of yet. We are using, it's in repairs and on structures that are in design or being rehabbed. We haven't used them, say, like in a invert repair, but that's something we could, potentially look into.
When you divert the flow or dewater for a pipe to pave it, have you ever had problems with groundwater infiltrating through perforations or seams, and how do you handle that or deal with it so you don't get a screwed up water cement ratio?
Maybe, and if I can tack onto that, because we had a question also so related to that is what water diversion techniques have you used? Maybe you can answer that at the same time that you found work best.
Pretty much the two that our contractors use are either a bypass pipe or they use a pump. For the most part, they've had good luck dewatering. Sometimes we'll have to, say, set up another pump at the outlet to catch any dirty water that comes through there and put it up into the tall grass, and hopefully it doesn't get back into the stream.
For our in-house staff, they'll usually sandbag off and then pump around. For the larger ones that go to contract, a lot of times they'll replace one barrel at a time, put a pump or a pipe through the other cell to get the water going around. Depending on the waterway, they might have to assist her with pumping a little bit too. Contract-wise, they typically don't have too big of an issue dewatering. Our in-house maintenance guys, sometimes they do. Some of these pipes are in low areas that are just constantly wet, so you can never really get it dry. So sometimes they're installing these things in a little bit of water, unfortunately.
Same thing in New York, sandbagging, pumping, and I haven't heard of any issues that we've had. Yeah, we're probably putting all the dirty stuff up in the woods and hoping that it infiltrates in.
You have a detail actually for what you're talking about exactly, where we call them pissers, where in other words it's coming through at the 3 o'clock and you've got water coming in. What we'll typically do is the contractor will work from the high side and start cutting holes into the pipe in the bottom, dig a pit, put a sump pump in there and pump the water out and draw down that water elevation, pave above that line, and then work its way down. So essentially you work your way down the pipe. Obviously the hydraulic pressure will be relieved as you go along, but that is a problem. We've done also injected grout underneath, like, I don't know if anybody's in this room's been in it, but when you go into some of these pipes, it's like potato chips. The pipe's completely gone, so it just crushes under your feet. So what we'll do is those openings, we will actually clog all those or block all those to prevent the water from coming in. Even doing that, though, sometimes we still have to cut the hole in the pipe, dig a deep pit, and actually put a pump in there and pump the water out and pump it down. All our water goes through they call them a dirt bag or whatever, but it's a giant bladder that basically takes out all the sediment, the water drains back in. When it comes to diversions, we've used a hydro dam system, we've used a concrete barrier where actually they put sandbags to line the bottom. Depends on what your bottom is. If it's a granular, obviously you get a lot of seepage, so therefore you got to pump behind that dam to drain it into that dirt bag. But we've used barriers where they wrap them in plastic, jersey barriers, and actually set those in the stream on top of the sandbags. And then also just if it's a small stream, you just use sandbags. So we've used a variation of those, and we've had, hydro dam, ported dam, all those different products, and they all seem to work well. But they all depend on what stream you're in that you need to use them.
Can each of you define what you mean when you say culverts? Or is it like 5 to 20 feet? Is it up to 30? Is it 10? Can you maybe just define that for us?
I know we're working on one that is like, I think it's like 12, 13 feet. So that's probably about the largest that we've ever done a rehab on.
In Delaware, we have what we call state length bridges and then MBI bridges. The state length bridges, we actually go down, it goes by hydraulic opening. So we say 20 square foot, a minimum 20 square foot opening, and a vertical opening of 4 foot. So essentially 2 4-foot pipes would be classified as a state length bridge. There's not a whole lot of those, but there are some. Typically our state length bridges, they're in the 5 to 6 foot range per barrel. And then, as far as the larger size ones, they're in the range of maybe a 16, 17 foot span. Every now and then we might have a handful that are beyond 20 foot. and like they're on footers, but most of them are probably in that 8 to 12 foot range.
Technically, in New York, it's 5 to 20 are the large culverts. Small culverts are under 5. A lot of the regions don't play nice together, highway versus bridge. So bridge, they're responsible for bridges over 20 feet, and the highway side of the house, the resident engineers are in charge of the large culverts. They're inspected, biannually. There's also the debate, I guess, of the culvert versus bridge and who should work on it. If a culvert doesn't have any fill over it, we try to get the bridge crews to do that because they know, obviously there's no fill, so the riding surface is basically the deck, and no matter what size it is, even if it's 10 feet, But if there is fill over it, then we kind of call it a culvert, and it's the highway sides.
To not muddy the waters, but the fact that we just call culverts, you can have a pipe culvert that is a bridge, and because it's greater than 20 feet, but you can also have a box culvert that's a small structure, but it could also be a bridge. So, the idea, though, is it's not an indication of its length or size, whether it's a bridge or small structure. It's the type structure that it is the way I would presume, is that a box culvert and a pipe culvert are the structural type, and then whether it's a bridge or small structure it depends on the size.
This question is based off of aluminum pipes. We notice that a lot of times aluminum pipes corrode from the top down, so you find most of your holes in what would be the ceiling of the pipe. Other than replacing it, have you guys had any experience with repairs that can be done in order to prolong life?
I don't have any experience with that, I'm sorry.
Yeah, we've actually we have a couple aluminum pipes, and we've done analysis of the soil by taking samples out to the outside face, like in other words, you get those little rust dots, like you're alluding to. They're all over, top, sides, wherever. So it doesn't make sense why they're there until you actually test the soils and find out it's corrosive soil. In the areas, if we can tell where the soils are, that it's like concentrated in one area, we've actually injected it to try to neutralize it and see how well it performs. Other than that, then you're looking at, okay, what do you do replacement? Now we have, Mo's office has a job that he just put out. It was an arch on US 1, big. It's like 5 giant arches, and the northbound is all good. So it's and it was continuous. It's 2 lanes each side with shoulders. So all the fill on that side was okay. All the fill on the southbound, the thing looks like it's 100 years old. It's fallen apart. So basically, in that case, because it's being an arch, it has enough ledge of the footing, we're actually going to install a concrete arch inside the corrugated pipe itself. And by doing so, reestablish that structure. The corrugation, by the analysis, is going to be that concrete arch that we built inside there is now the new structure. The corrugation is just basically became a form. One thing I did have Mo's project engineer, who now works for me, is to actually coat the inside of that corrugation with a inhibitor so that the corrosive soils could not get to that new concrete invert. We didn't want that to start reacting and have the same problem. So this is a permanent repair on something like that. But when it comes to a small pipe, like the one that I'm thinking of that we have is like a 6-foot diameter pipe where you have those, it's a hit or miss. If you can't get it replaced and you're just trying to avert one spot or a couple 30 feet or 40 feet, you can inject behind it.
John's with DOT. So in Delaware, like John mentioned, for aluminum, it's typically on the top side of the pipe. Coincidentally, it seems like it's always directly under the roadway. The part under fill, so we think it's salt related, de-icing agents. Unfortunately, by the time you see it, it's rusting from the outside in, so there's not a, whereas, the steel pipes, a lot of times, they're kind of rusting from the inside out. So and you're seeing it until, you don't really see the deterioration until it's actually kind of came through already and you have the hole. We get a longer life out of aluminum structures. We get about 40 years, and then, whereas the steel is about 30. Interested to know, for other states and the panel members, what kind of life do you get out of your corrugated metal pipes?
Do you have a lot of these aluminum pipes?
I guess back to the first question, the aluminum, we haven't had any issues that I know of. We've used them for liners. I guess back to how long the pipes, I guess I've seen some that have lasted, probably 50, 60 years, and some that, it seemed like they only lasted 25.
The top-down problem, we have We haven't done it yet, but we have two projects to inject foam down around the pipe from the roadway surface down and like encase that pipe in that foam. These are on pretty high volume roads and would be really disruptive to do an open cut to replace those pipes. They're pretty big pipes, and they're on what we call culturally White Clay Creek. What do we call that? I don't know. It's the environmentalists are just all over White Clay Creek up in Delaware. It's a culturally significant stream. We're working in it is a big deal.
Back to your question. Yeah, it's about the same as Vermont. I think what we have found in the past is that where there's a high fluctuation of flow, those are the ones that are rotting the most. Like the ones that have, constantly water in there, yeah, you'll get rusting along the, that flow line. But, if it's drying out and then getting filled back in, those, obviously those are the ones that have the whale ribs on the bottom.
Yeah, we've had some pipes that have lasted for, 60 years or whatever, and now we're at the end of their life. But the issue, though, really, that we find is, we had one project up in one little town where they had actually put in a corrugated metal pipe, and it was all from the street runoff, and it was kind of a northern, it got a lot of snow or whatever, so they had a lot of snow runoff, and the salt just ate through it in less than 10 years. But then we have others that are, around 60 years. But going back to what Jennifer was just saying, a lot of times on our western, we have the coast, and then we have western Maryland, we've got steep slopes and a lot of rock that's in there. Well, you galvanize something, and then you have bed material that's flowing down, and it's just beating the crap out of that pipe. And within a couple years, there's no zinc on there anymore, so that thing just starts corroding in like less than 5 years. When it starts getting holes, it might take 10 years, but it really is a variation of environment that you put the pipe in to get the longevity out of it. And, maybe in the past they put heavier galvanizing on the pipe itself. But bed material is definitely one of the factors. And like I said, this one where we had a small town that it was less than 10 years. I mean, the pipe looked so perfect from, just at the bottom was like 1 foot was just gone because every one of those little troughs held salt water, and it just ate right through it.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.